Hello friends. By now, hopefully you have understood the basics of finite elemental analysis. Now, let's understand the advantages and disadvantages of this method. First, let's take a look at the advantages of this system. We have seen the importance of this method with respect to complex geometries by breaking the domain into fragments and individually solving the solution of each element and reassembling the model. Hence, we can say that finite elemental method scores well in all types of boundary conditions. Next, we can conclude that this method is highly compatible with respect to the material properties of any such understanding the material properties on the stiffness of your design. It also helps you understand the behavior between real material and properties. This method is also perfect for the time-dependent problem where the acceleration property cannot be left aside. Here, the time derivatives are used by finite elemental model to arrive at some spatial problems. In design field, the software of FEA can test any given model by applying the boundary conditions without testing the model in real life. This reduces the cost of testing the actual model and also optimizes efficiency while redesigning. Finite elemental analysis also helps in understanding to evaluate the transient problems by designing out the potential noise and vibration problems. FEA is a powerful tool which allows the engineer to design the product for the purpose of avoiding excitation to coincide with the natural frequencies of the structure. Therefore, to eliminate and minimize excessive vibration. Also, this can evaluate all types of boundary conditions. The main types of loading available in FEA includes forces, pressure, and temperature. These can be applied to points, edges, nodes, and elements or remotely offset from a feature. Even though the disadvantages of FEA score over the advantages, we must have a brief outlook on the shortcomings of this method. Let's see the first one, which says that the method of FEA does not give accurate solutions. In the discretization of a problem, the answer to every problem may vary from software to software. This method requires a lot of time as every element is discretized and solution to it is worked. More the number of divisions, more is the number of time taken. For FEA, we need a person who has a piece of sound knowledge in the system. Training every person who is new to the field is a tedious task. The person with knowledge in derivatives, integration, matrix solving can be used for this software testing. Software testing also requires a lot of data storage for saving the solution to a problem. Linear finite elemental analysis does not provide enough information about buckling to make correct design decisions, especially when designing lightweight components. Now, let's look at the application of FEA. We know that in static stress analysis, we get the relationship between the applied load and its structural response, which is linear, and the material follows an elastic behavior. Static FEA is based on the assumption that time does not play an important role and its influence on the results can be ignored. In the case of solid mechanics simulations, it means that the load and the response to it are static. In case of fluid mechanics and heat transfer analysis, it means that we only get a stationary solution when there are no temperature, velocity, pressure differences, and no flow occurs. So basically, all static analysis search for equilibrium state, be it mechanical or thermodynamical. For stress analysis, the model is split into small pyramids or cubes, a mesh of simple shapes that can be calculated by the laws of physics. Loads are applied to the mesh and displacements are calculated. For mechanical stress analysis, the review of welding geometry and terminology is done. The removal of critical stresses is also done with this software. Also, a review of fatigue analysis is also done using the testing software. In recent time, The nuclear power plants or NPP has become a major contributor to the world's energy production. However, NPP presents a great threat to the world's atmosphere. So, risk analysis is a major concern related to them. The use of finite elemental analysis or FEA has increased for the study of real-world structures of NPP. It predicts how an NPP structure will react to real-time forces, heat, vibration, fluid flow, and other physical effects. Finite elemental analysis estimates whether NPP will operate effectively or it will break down. It is used to test material against random vibrations, shock, and impact. Each of these incidents may act on the natural vibration frequency of the material, which in turn may cause resonance and subsequent failure. The model is constrained in such a way that the result requires specific considerations. Over and under constrained models which give stresses which are inaccurate and worthless to the engineer. So, if we talk about the advantages of FEM, we can say that FEM is used moreover in static analysis, stress analysis, mechanical analysis, and also they are used in the stress analysis of teeth and bones, nuclear analysis, and vibration analysis. That's all for today, students. Thank you for watching the video. Please subscribe to Ekeeda and stay tuned.